everyone, it's Caroline Wu here in Beijing. It is the 110th anniversary of Tsinghua University. So today you are going to follow me to Tsinghua University Science Museum that celebrates the glorious achievement of science and engineering in modern Chinese history and the pioneering spirits of its scholars. So joining us today is Dr. Lu from the Tsinghua University. Welcome. And also an undergraduate from Tsinghua University, Adrian. Welcome, you guys. Why don't you guys introduce yourself a little bit?
Thank you. My name is Christine Luk. I am Associate Professor at the History of Science Department. I'm very happy today to give this walking tour of our Science Museum under construction.
Thank you so much. And Adrian?
Hi everyone, my name is Adrian from Germany, and I'm currently a bachelor student at Tsinghua University in the School of Social Sciences. I'm very excited for today's tour.
Great, thank you so much for joining us. All right, why don't we get it started? And why don't you give us a little bit introduction of the museum, Doctor?
Sure, I'll happy to. Last weekend, we just celebrated the 110th anniversary of Tsinghua. So right now, what you're seeing are some donation by our alumni. So the box here shows the latest set of donation from this particular alumni, Wang Guanghuai. So he graduated from Tsinghua, as you can see here, from 1958. And ever since he heard our Science Museum, he was very passionate. He donated all these.
These are cameras, are they?
Yeah, these are old types of cameras.
And old types.
Yeah, early 20th century. And his own expertise was on these other mirrors. And he wrote these books, by the way. These are the books that he wrote.
He wrote?
Yes.
And they all donated to Tsinghua University.
Right.
Wow.
So you can see the brilliant achievement of the previous generations of our alumni. So why don't we get into the exhibition hall?
Just a second. What are these little tools? Very adorable, and they're tiny models of some farming
agricultural tools. Yeah. So you can see there are cameras, definitely. Agricultural farming tools, but there are also other type of heating tools, right? Stoves. And also right here, the metrological metrology, so 度量衡, right, standards.
I do remember this. I don't know if you guys or Adrian have visited the art museum. There's this exhibition dedicated to the ancient bronze mirror. I hope it's still going on right now. Yeah, it looks exactly like this. This is from the Yuan Dynasty. If you guys have visited there, or you guys have been watching us, last week we visited the Tsinghua University Art Museum. It's also, to celebrate the 110th anniversary of Tsinghua University. So for those of you who are watching right now, please say hi to us. We got fans from all over the world are watching us, and please ask any questions. Let us know any questions. Dr. Lu, Christine, is from Tsinghua University and going to provide us a lot of information about the exhibit here today.
And just to add on what you said about Arts Museum, so what you see here is not the permanent address of the Science Museum. This is just a temporary exhibition hall. Now, the permanent location of the Science Museum will be located next to the Arts Museum. And it will start construction in 2022. So, and this is why I hold this book, because it has nothing to do with Tsinghua, but after our permanent Science Museum is finished, it will be modeled after the Whipple Museum of the History of Science at Cambridge University. Because at Cambridge, their museum and their department are integrated. So, so it's not just a museum for museum's sake or department for department's sake. It's really one integrated structure housing both the teaching, the research, and the collection of scientific instruments.
Wow, great information. Thank you so much for sharing that. And we got William Jones is watching, and Jesse, hi there. And also we got Sylvia, hi Sylvia, and also, please share and like this video. Let's keep on going. And tell us, Dr. Lu, what is this hall about?
Yeah, so what you're seeing right now is the founding exhibition of our museum. It's called 百年气象, a century of instruments. So the century here refers to the century of the founding of Tsinghua back in 1911. And the whole purpose is to tell a fuller, richer history of Tsinghua via the standpoint of scientific instruments.
Yes.
Because we heard so much about the history from documentation, written words and pictures.
Yeah.
But what is lacking is materiality, right? So here we collect all these collectibles with a specific Tsinghua touch. So for example, if you allow me, so this table here, the square table, it was used by one of these founding a very famous scientist here at Tsinghua. So he never married, but he was the teacher of some, at least I think 50 or 60 very famous physicists at Tsinghua. And many of his students participated in this very famous project, techno-science project known as 两弹一星.
Yeah.
The two bombs, one star.
One star, yeah.
Right. So the atomic bomb, the satellite, and also the missiles. Right.
Exactly. Yeah. And we are about to show you guys a photo of his students and his students of the students.
Right.
Over here on this side, just a second, but this table is used by him.
Right. So
old-fashioned square table.
Right. So he has been used this table.
Oh, okay. It's been donated.
He's done a lot of amazing work on this table.
Of course. See, it's classic.
Yeah.
Okay. All right. Let's keep on going. Take a look over here on this side.
Right. So the picture here, the portrait is. Dr. Liu Xianzhou. So he was former vice president of Tsinghua, and he was a founder and a pioneer in mechanical engineering in China. And these are the sets of
tools or rulers? Or
like map drawing tools, cartographical tools. So purchased by him, but also used and preserved by him. So, for example, especially here, these are not just drawing for map. This is the pole planing tool. So, it's one type of the precision tool that you use if you want to accurately portray the points on a plane.
Wow. Right. Okay.
And then over here, so you see the same Dr. Liu. He was standing next to this foreigner, right? He was very famous. He had a Chinese name, Li Yuese, Joseph Needham. So he is very famous for writing this multi-volume book called Science and Civilization in China. So he was a founder, very important historian, actually from Cambridge. Right.
Oh, okay.
Yeah, from Cambridge, but he was very good friends with
Dr.
Yeah, but also very important politicians such as Zhou Enlai. Are good friends with him. So very important. So these are some of the instruments from that time period. Over here, you see the liquid limit meter. This is used for measuring the water content in soil. And if you look at the date from 1947, right, it was so many of these are instruments because from that period and with the American connection, because Tsinghua was founded partly as the Boxer Indemnity Scholarship Program, and so many of these instruments had some kind of American connection. They were produced in China, America, and then purchased, preserved. By Tsinghua students and I'm sorry.
No worries. So we got a photo. So these are his students, right?
Right. So I should actually say that from the beginning, our exhibition is divided into 3 parts, right? 3 sections, right? And they are chronologically ordered. I'm sorry. So the first part dating from 1911.
Okay.
Right, and then the second part from 1949.
This part is called
transformation by endeavor. Right. And then the third part,
innovation.
So after 1978, after the 改革开放. Right.
Okay.
Right.
Yeah.
I should have said it earlier.
No worries.
And okay, so here the picture that you pointed out, right? So these are a bunch of young people, and their average age is around 20 or 23. And they were working for the Heyuanyuan, the Institute of Nuclear Research at that time. And many of these young people, some of them, they were active in major techno-scientific projects. So the big portrait here you see, these are the famous scientists and engineers for the Liangdan Yixing that I just mentioned, right?
The 2 bombs and 1 star.
Right,
project.
2 bombs, 1 star project. And many of these names are very well known, including Qian Xuesen, right?
Yeah,
Deng Jiaxian, Wan Xiji, right? Zhou Guangzhao. So you recognize all these names. And over here, these instruments were used by these young folks in the 1960s.
Wow, they were very young. Just want to point out, like this living condition. It's like a rural area.
Yep.
You can see quite many amazing things, wonderful things that was done in such a, I'd say, you know, poor environment by them. This is just incredible.
Yep. That's why in this section we want to emphasize the endeavor, right?
Yeah.
The hardship that they overcome. So many of these measuring devices, for example, this is the DC galvanometer, many meters, right? And AC transformator. So for measuring different types of electricity, electric current, electric resistance, etc. Oh, and especially this switch here, you can see with Chairman Mao's aphorism.
Oh, okay. This is like you turn it on.
Right. So it's an electric switch. Right.
Very interesting.
But many of our visitors particularly like this.
Yeah. That's right. That's so cool. All right. I just want to take some time to say hi to our fans everywhere. We got Jessie and Sylvia. Thank you so much for watching, and please say hi and share and like this video. Yeah. Go ahead.
So this is a electric, OMNometer. So an OMNometer is a type of meter measuring electric current, but this one is equipped with clamps. Right. So again, if you look at the date, 1958, and it was manufactured in the former Soviet Union because at that time, and you can tell the history of the Sino-Soviet collaboration, and then later on the split from that time on. And so basically we just walk from instruments produced in the US to here with just a few steps, but what we are crossing is a very significant transformation of history.
Okay? Great to know that.
No, this is an optical instrument called theodolite. Right, so here we hold many instruments of optical and metrological types. Right. I think you want me to introduce this one?
Oh, this one. Let's go take a look.
This is a high pressure sterilizer. Right. This was made in the U.S. in 1948, and it was precious because it was one of the few precious highlights from the School of Environmental Science. Right. And now with the pandemic and whatnot, so sterilization, right, becomes a high, becomes a focus. I think one of my colleagues, one of my postdocs, wrote a paper about this prototype.
Yeah. Okay. So this is a instrument that comes with a light. Looks like there's a lamp comes with it. What is it?
So this one, right? He is a precision machine tool. This one, the date was interesting. Yes, I remember the history here. Made in Switzerland, and this was purchased and transferred to China via Hong Kong.
Okay.
Yeah, because of the at that time the embargo. So any high precision tool, I mean, it doesn't look precision now. At that time, it was really high tech. It had to transfer through some other hubs such as Hong Kong or Macau.
It was pretty precious at the time, hard to get and very precious.
Yeah.
Okay. Let's take a look. This one?
Yeah, so okay, this is a mass spectrometer leak detector. So I think it won some prizes, if I remember correctly. Right, so 1964, the first prize, National Science and Technology Commission. So what it did is it used mass spectrometry to detect any leakage in vacuum. So in any vacuum science, you want to know whether the vacuum is actually vacuum. So so how can you be sure that it's actually leak safe, right? Then one of the most remarkable reliable ways is to use spectrometer to detect the leakage. Okay.
So whoever is there watching, please say hi to us. I saw Kenny just started joining us. We're here at Tsinghua University Science Museum, and this is
the sort of the
innovation beyond the limits.
Right. So we are now walking into the post-1978 period. So since 1978, because of the economic reform opening up to the world, so we see an influx of innovative technologies and also importation of many latest scientific instruments. So, for example,
I know
here,
this is microscope, right?
Yes,
this time it's gotta be right.
This is a Leica branded fluorescent microscope. Everybody knows about Leica.
The camera is good, right? The camera is perfect. I have one.
Right, and this one was donated by the School of Life Science. And did you see the marking DEV?
DEV?
Right, it stands for Developmental Biology, 发育生物学.
Okay, okay, gotcha.
Right, right. So microscope is not only useful in chemistry, astronomy, but also in life science.
So this.
These are so the three here I can introduce together.
Yeah.
These are equipments used in telecommunication. Okay. So I think this is the microwave relay. Right. So I'm not an expert in wireless technology, but now everybody was so used to mobile technology, right? But if you think about the technological base, here, so they need relay because with microwave, it can only transfer up to a certain space, and then you need a relay machine to pick up the signals. Right, so this is a prototype made by the Tsinghua University Department of Wireless Technology. Right. And I do remember this one particularly because it looks just a box, right? But it's really important. This is the Terrestrial TV, digital TV standard test type. So so nobody really watches TV now. Everybody watches 直播 now, right? But if you still remember the TV era, in the past we had the analog signal. And then later on, it developed into the digital signal. And in the analog signal era, all the standards were the, I guess, Western European standards. But when the analog signals transferred to the digital signals, so in 2005, Tsinghua decided that they wanted to propose their own signal, TV signal. So to do that, you need to provide your own kind of prototype, right? And this signal actually had a name, and it was approved by the ITU, the International Telecommunication Union, I think. Yeah.
I just want to point out, take a look at what the photo behind us. Is this a photo took in, like, way back
in the 80s.
80s.
Yeah. So this is a very famous, one of the earliest buildings on campus, Tsinghua Xuetang. So it harkens back to the founding period when Tsinghua wasn't really called a university. It was founded as a Xuetang, as a Liu Mei Yubei Xuetang.
Okay.
Right, because of the Boxer Indemnity Scholarship. So the students, they were here and to get preparation to be sent to get education in the U.S. And that's why Tsinghua Xuetang is very famous. And now on campus, one of the major boulevards is called Xuetang Lu. Because of that.
Yeah.
It's not called Xueyuan Lu, it's definitely Xuetang Lu.
The Science Museum, is it on Xuetang Road, is it?
Right?
Yes, it is.
Yes,
yeah,
yes.
So
Well, good point, good point.
So if you just started joining us, we are here at Tsinghua University Science Museum, and joining us today are Dr. Lu from Tsinghua University, the professor here, and also an undergraduate Adrian is also from Tsinghua University. So please share and like this video. Yeah.
Oh, yeah, and we want to share some of the innovative projects by our students. So at Tsinghua...
competition, take a look at those photos. These are all competitions that attended by, is it like Tsinghua University students? Or?
Yes, so every year, well, for at least 16 years, we launch a competitive science project-based competition known as the Challenge Cup. Okay, 挑战杯. So students were encouraged to illustrate their brilliance, right, with their invention. So this one was widely, creativity. So they were widely celebrated. The student, he was from the School of Automation, car manufacturing.
Yeah.
And this one was a, let me see, so it's a car engine, right?
Yeah.
And again, I'm not an expert in car manufacturing, but in car engine, when you use internal combustion engine, one of the major problems is that the energy efficiency is quite low. So I look at the abstract here. This prototype can fix one of the major problems in the crankshaft rod. Right, so it can increase significantly the energy transfer in internal combustion engines. So there was one.
You can see from those photos how Tsinghua is encouraging students for their scientific innovation and promoting the science communication from those photos. So I don't know if you have attended all those competitions. Can you? Can students from other departments?
Yes, of course.
Yes, of course. But I never. I just think I'm a freshman.
You're a freshman. Oh, okay.
In the future.
In the future.
Yes.
Yeah.
Sure.
You're gonna see the picture here. Did you see the
video
TV, the video Selfplaying Xylophone, right? And it was played by this machine. Yes, so it was a xylophone, but it was remade by a team of students, right, and a professor. And the idea was to, you see how now on the internet there is all these MIDI musical notes, and so this xylophone can actually play automatically according to these computer-issued notes.
Oh, okay.
And the result is this.
Interesting. It's like an automatic piano that you see nowadays, am I right?
Right, right. But this is xylophone.
This is different. Wow. So these are all the award-winning works by the students that are collected here.
Yeah.
Wow, that's impressive.
Yeah.
So
right. So here, these are also the well, I guess self-innovation, right? So you see, now very familiar faces. So basically, back in 2003, during the SARS outbreak, one of the major problems at that time was how do you do a rapid temperature check at border checkpoints, over a large number of people. Now, at that time, there were only traditional mercury thermometer or digital thermometer by using the ear thermometer. Right, so these are, well, very slow and invasive. So this temperature check machine was developed by Tsinghua as a response to the need of doing rapid temperature check over many people. So what it did is it can recognize feverish bodies apart from non-feverish bodies with infrared technology.
This one, right?
Right, so basically you can just walk, right? If it is useful, if let's say there are 50 people just walking, right, then we can see, at least identify who is feverish from who is not feverish.
Wow.
Now this is common, but at that time it wasn't, right?
So this is the goggle that's also developed by Tsinghua University.
Yes, yes.
Anti-fog?
Yeah, fog resistant.
Fog resistant.
So now medical health workers, they have to wear goggles, right, in the hospital. And one of the major problems is that they got foggy very easily, right, and affects their vision. And so now this goggle, this particular type is equipped with graphite. Graphene, I think.
Okay, so this was developed in 2020, just last year.
Yeah, you see that. Yeah, this is by the Tsinghua in Shenzhen. So at Shenzhen we had
research center.
Right, very good. Yes, yes. And over here we have a robot, and then the researchers name it Atu.
Okay.
Because Atu is a name of the Mensen, right?
The door, God?
Yeah, God
of the door.
Really? So they're guarding the safety.
Oh, I see.
Yeah, so now it's common. You can find it at the entrance of every cafeteria. I'm sure you've seen it.
Yes, I'm familiar with it because every day when I go to eat, I see this, and I need to, check my temperature with it. I'm really familiar with this machine, so we go way back.
Yeah.
Okay.
So this is developed by Tsinghua, and I think so this is non-invasive because without that, I think in some places the health check.
How does it work?
Yeah, you just put your hands, maybe your wrist down there, and then with the infrared, and then they would tell your temperature.
Okay, like this. That's way easier.
36.3 instead of holding a temperature gun to your head or something, right?
Yeah, that's way easier.
Right, yeah, non-invasive, and also avoids the risk of cross-contamination.
Exactly.
Right.
No touching.
Right.
Yeah.
Right.
This is also developed by Tsinghua.
Yeah, I guess the final item I want to show you, this is a all-in-one SARS-CoV-2 rapid test, right? So it's also developed by Tsinghua in collaboration with the Beijing Municipal Science County. So the aim is to...
Can be used at home? Like, is this the one can be used at home to detect the virus?
Right. So I guess some people would question the accuracy, and rightly so, right? But then I think the good thing about this is availability, and it's very convenient. So you put the sample. This is called the sample in one lever, and then you wait 30 minutes, and then you get the results out.
That's really fast.
Right, right. And the downside is that, well, about questions over accuracy, and also you don't have a proof whether you are negative.
Oh, I see.
You know for yourself.
Yeah. Great. I think that should be much about this exhibition hall, and I really wanted to thank you, Dr. Lu, for joining us. And let's go over there, and we're going to enter another exhibition, and we are going to have another guest. And thank you so much, Dr.
Thank you for having me.
For joining us. Yeah,
yes.
can I have the mic?
Yes.
Thank you.
There you
really
go.
appreciate that.
No, thank you for having me.
Thank you for providing us all those information. Yeah, let's go, Adrian. And we are about to enter another exhibition hall. We are going to have a little kid join us. Hi. Hello. Why don't you come over here? Hi. This is Zongshu, right? Introduce yourself.
Hello, everybody.
Yeah, come over here.
At Tsinghua University High School.
Yeah. Oh, you go to high school? Not middle school. Middle school.
Wow.
Why don't you clip it somewhere? Can you clip it over here?
Okay.
Yeah. Or you can hold it. It's up to you. And I'm impressed. He's a little kid, and he's going to provide us information for our next two exhibitions, which is about calculators, about computers. Yeah, ancient and modern calculators and all kinds of computing equipment. That's impressive. Yeah.
This exhibit is divided into three parts. The first part is the manual tools. The second part is the mechanical calculators. And the third part is the electronic computers. The first part, the manual tools, is pretty simple. There are tools that only aid in calculation and don't actually do the calculation themselves.
Yeah.
For example, these representations of numbers using hand, that's the most basic form.
Yeah.
There's a lot of different systems of doing so all across the world, and each of them is different. This is one example.
This is like real hands, right? They look so real, right, Adrian? Do you think they're...
You can see
yeah,
the
you can see the
modeling
texture. This is real, right? Are they real?
They look real, at least.
I think it probably took
I heard that the
Some-
staff said that they are
Yeah.
actually made by...
Some systems can even go as high as 9,999
Wow.
with
Okay.
hands.
Interesting. Okay, keep on going.
So these are some ropes,
Mhm.
and they're not on the ropes.
Yeah.
These are the 球谱.
Ancient way to do the calculation, I guess, to do the measurement. Am I right?
Actually,
Cool.
no, these
No?
are just still, these ropes just represent numbers. However, you can represent much bigger numbers than hands because there's no limit to the amount of ropes you can use and the amount of knots you can put on the ropes.
Wow. Okay. Gotcha.
And up next is the Mesopotamian clay tablets. These clay tablets have symbols to represent numbers, and written here are all the fractions of 60. For example, half of 60, 1/3 of 60, 1/4 of 60, etc. It's 60 because the Mesopotamians used a base 60 system as opposed to base 10, which we use now.
Okay.
And that's probably the reason why there are, 60 seconds in a minute and 60 minutes in an hour.
Okay. I don't know what he's saying, but do you understand?
Nope. But I think it's really cool.
Whatever you say, you're correct, because I'm really not good at math. But I know that you are really, really passionate about math and mechanics, right?
Yeah.
What do you want to become in the future? Let's keep on going.
I want to become a mathematician.
Wow. Okay, you can definitely do it. Okay, take a look at this section. Yeah. Go ahead.
And this is the Chinese counting rods. That is the Chinese abacus.
Abacus, yeah.
They use similar principles. They use base 10 like we do today. And they represent each digit by some combination of symbols. This 1 is 1 stick. And this 9, say, is 4 vertical sticks and 1 horizontal stick.
I noticed that the difference from the Chinese abacus and these are from Russia, it's from Japan. They look different, do you think?
Yeah.
Right? Am I right?
Yeah.
They're right. They're different, right?
The different
Yeah,
details,
but they look definitely very similar.
They look similar, but if you see the details, take a look at the details. The shape of those beads are different, and
yeah, they operate using similar principles.
Okay, I see.
And this is much more compact than this. This is just a 4-digit number and you need this much space. And on abacus, you can represent the same 4-digit number with this little space.
Okay, interesting. Yeah, take a closer look. So whoever is there watching, please say hi to us. We are here at Tsinghua University Science Museum to walk you through. This is the section that is called Ancient and Modern Computing Equipment. Am I right? Like
The history of calculators?
The history of calculators, yeah. So we're having this little middle schooler join us to provide us the information. He's really passionate about mathematics. Yeah, keep on going. Some bamboo slips here.
So
yeah.
this is the 算表, another Chinese mathematical object.
Yeah.
It's basically just a multiplication table, but there's the multiplication of halves, such as 3.5 times 6.5 here.
This is
So
from...
it's an improved version.
Oh, this is from like ancient China. It's from Warring State period, like
300 BC.
300 BC. Wow. Wow. The bamboo slips are being put to good use back then.
And this is a very important achievement in the history of calculators. These are Napkirs bones. I have a model right here. So Napkirs bones are basically yet another multiplication table, but each column is one separate stick. And these numbers on the multiplication table, the results are arranged like this, with the tens placed here and the ones placed here.
Okay.
it's very useful because you can obtain results just by adding. Let's do some. Let's multiply 1928.
1928. Okay, we got 19 and 28 here.
By 7.
By 7.
Now, you can see we ignore everything except the 7 row. So we have these 4 squares.
Yeah.
And we look around the diagonals. So then we add the numbers in diagonals. 0, 13, 4, 9, 6. And we have to carry on numbers manually. So it becomes 13,496.
Okay.
It's a very convenient way of doing multiplication.
Oh, interesting. That's how people back then to sort of like using this tool to do the calculation. Huh, very interesting.
These are basically complicated geometrical tools.
Rulers.
Yeah, they're rulers. And also protractors at the same time.
Yeah.
And compasses. They're very useful in drawing all sorts of diagrams.
Yeah. How about this way? Let's take a look. These are they like interactive? Can you?
Yeah. Okay, we enter the second part, the mechanical calculators.
Okay.
Now we can use gears. You can see these gears.
Yeah.
These gears actually do calculation. Not this one. This one's an odometer.
Can we touch it?
Yeah.
Is it allowed?
If
Okay.
you turn this handle, there are balls placed inside here.
Yeah.
When we turn this handle, this wheel moves slowly.
Wow. Okay.
Every once in a while, a ball falls down
balls here.
into this
Crystal
compartment.
balls here. Okay.
And the point is, at a fixed interval, the balls fall in.
Yeah. Wow. Okay.
And
Genius.
that can help us calculate the speed of the wheel and how far we travel, etc.
Oh, okay. So are they together? These things together? This separate tool?
Oh, they look connected.
They look connected, but it's actually not, right?
It's 2 different objects.
Okay. But like, why there are some little figures on top of it? Looks really interesting. Not like a tool to do the measurement.
Yeah, this is another
Calculation.
Chinese odometer.
Oh.
If you turn this wheel counterclockwise.
Clockwise.
Like
here.
Yeah.
Like this. Yeah.
Then after a certain amount of time, the drum is hit.
Okay. Oh. Okay. One more time. Can we do one more time?
Yeah.
After a certain amount of time. Oh. Okay. Cool.
And the drum is hit again and again.
Okay.
And you see this?
Yeah.
When this finally touches that block over there, the bell is hit.
Interesting. Why does it have anything to do with calculation?
Well, it's basically not really a calculator, but it's an odometer, a way to measure distance.
Okay, I see.
And when, like, this is like a cart, right? When this goes forward, this wheel turns, and a fixed distance, these things are hit.
Ah, interesting. Thank you. Great job. Great job. And do you want to tell us something about this? Take a look over here. Yeah.
We shouldn't talk about this yet.
Oh, later on?
So
this is in chronological order?
Yes.
Okay.
So next up, this is the Antikythera mechanism.
Yeah.
Basically a device to predict solar eclipses. This model, which doesn't work, by the way, if you turn this, you can see this is the sun, this is the moon. And when they overlap, a solar eclipse occurs.
Yeah.
And at the back here, these are these Greek years system, a complicated system to track the passing of time.
Wow. That's sophisticated. Wow, genius. Yeah.
That's the Lego model.
That was about to say that. The Lego model. So mechanics?
Yeah.
These are like a machine, like an inner part of a car.
These things all use.
These are machines.
These gears.
Yeah, these gears.
Apparently, you're supposed to turn this. I think. That's the sun. That's the moon.
Okay.
It operates similarly.
Yeah. Lego model. Okay. Interesting. This thing? Do you want to tell us something about this?
Well, this is another
Calculator.
big breakthrough in the history of calculators because it allows you to carry on digits. For example, if I turn this, it counts. Let me just reset this back.
It's like setting your password for your luggage.
0, 0, 0, 0, 1, 2, 3, 4, and when we reach 9, the next is 10, and it becomes 10. So it automatically carries on the digits for us. Similarly, you can see it becomes 100. Now, the problem about this thing is that it gets jammed. If there are like many of these
gets jammed, really?
Well, it does not get jammed in this case, but of course this is a simpler model.
If there's like more,
like a whole
bigger
row of these things.
Yeah, that's right.
This thing solves the problem of getting jammed because if this carries on, then you can see everything falls into place and there's no opportunity for anything to get jammed. Problem is that you can't turn it backwards, so you can't do subtraction or anything.
So that's...
And you use these things to do subtraction. So these are basically this number 9 minus this number.
Yeah.
These numbers add up to 9.
Yeah. Sorry.
And so these are called the complement numbers. And if we want to do like something like 4 minus 5 minus 3, say, then first we take the complement of 5, that's 4, and then we add 3 instead of subtract. We can add here. And 4 plus 3 is 7, and we take the complement of 7, which is 2, so that's 5 minus 3.
What an elaborate design back then. So these are look...
Actually, we shouldn't be talking about this yet.
So this one, okay.
Let's go
Let's go.
Thing.
Let's go to that thing. These are all look so exquisite.
Well, this is another, how can I say it, a quality of life design.
Quality of life design.
Yeah, you can call it that because well, normally if you want to add, say, 5, you'd have to turn this wheel 5 times. Like, which is a pain. Yeah. But if you flick this to the 5, you can see this object right here as 1, 2, 3, 4, 5, these teeth. And when you turn this, it automatically goes through 5 teeth and adds 5. So it's a way to add like larger numbers with just one turn of the wheel instead of having to turn it multiple times.
So we have Michelle Tassa. Just started to think about you guys. I think I should say hi to you. We still have a lot of fans here watching. We have Michelle Chow and Jesse and Eric and okay, so we got a question. I think it's a good one. I guess probably you can answer. I have slide rule calculators that used to belong to my dad. Did they use slide rules in Asia?
Well, slide rules, we have to go all the way back there.
All the way back there. We have it? We do have it.
Slide rules are over there.
Very good question. I think it's Eric asked that question. Great one. Yeah,
so the slide rules, basically, they are like normal rulers, but the markings are different. So a normal ruler would expect 1, 2, 3, 4, 5. On a slide ruler, you have something like 1, 2, 4, 8, 16, 32.
Yeah.
So it's every number is twice the previous number.
Okay. Great. Thank you.
And when it slides, it can do multiplication very easily. You see, between the 1 and 2 markings, there are other markings such as 1.5, and they are spaced according to logarithms. If any of you know what that is, a property of logarithms is that.
Okay.
Well,
great job, though. Great job.
Slide it so that some way, if you read off the markings and then slide in the correct way, it just computes multiplication instantaneously. Great job. I hope that our little guy over here answered your question. Great job. Yeah, let's keep on going. Well, I don't know if they actually use this in Asia. Probably not. Let's keep on going, and we are also having another exhibition hall that is waiting for us. Let's go to the other one, shall we? Yeah. Oh, I have another. Yeah, let's take a look at this one. And these are all machines. They are all improved versions of this thing and that thing. And so I am going to perform a multiplication on this machine. Yeah. First, let's do the same multiplication. 1928 times 7. We first shift this to 1928. And then we turn this knob, and you can see that's the answer. This reading here, it tells us how many times we have turned this knob. So 7. And here is the answer. 13,496, the same as we computed in the Napkirs bones, and well, there's even more. If you happen to do this, it shifts to the second position, and here you can do as if you're turning it 10 times per time. So it adds 10 times this number to here. So effectively, you can compute, say, this number times 37, which is 71,336. Okay, great. Thank you so much for providing that information. I hope Zongshu, his name is Wu Zongshu, answered your question, Eric. And now we are going to another section. Yeah. And we have Michelle Cha and Sammy joining us. Thank you so much for joining us, and please share and like this video. So, Zongshu, tell us, what is this exhibition hall about? I see a whole bunch of computers. Yeah, these are all electronic. Electronic. All of these back there are mechanical, and these are all electronic. Yeah, let's go. Let's go. How about this one? Well, that's the very modern computer right there. Okay. So let's start from the basics. Over there? Yeah. This is computer? This is one of the earliest computers. You can see they're nothing like the modern computers, but they're a start. Okay. The computers back then were very buggy and slow and huge, very clumsy, and they practically all use the von Neumann principle, which is to have an input system, an output system, and other things like the CPU and stuff. Yeah. This is a very complicated design of the computer. Wow. Okay. Go. And how about I tell you the story of Bill Gates? Bill Gates, let's take a look on this section, this window display. Yeah, let's take a look. That's the photo of Bill Gates. Yeah. Oh, over here? It starts over here. Starts over here. Starts over here. Okay. Go ahead. When Bill Gates and Paul Allen, another of his friend, was in their 20s, one day they saw a poster like this on the street, and they thought, well, we know how to code, so let's brag and say that we already coded some code for the company. And of course they had written nothing, but when the company heard about this, they actually went to code the computers, and they actually did it before the company, before they met with the company.
I have to tell you that a lot of our fans want me to tell you that you are such a smart young man. You are really brilliant. And James tell me that, Caroline, you got to tell that tell the person he is a smart person. He rocks. Great job you did, right?
Thanks.
Great job, yeah. Take a look at this window display here. There are 8 computers here.
These are the original computers from
That
Bill
photo.
Gates and Paul Allen's 2 photographs together. The first one was in 1981, and there was 6 computers, and they decided to do it again in 2013. But 2 of the computers, they couldn't find 2 of the computers.
Yeah, for sure.
So they 2 replacements for the 2 computers. But now, all of the computers were found, and they're all here.
By Tsinghua University.
Yeah.
Yeah.
All of them are now here on display.
Yeah, wow, this is a great job that Tsinghua University has done. So the photo that was redone in 2018, that was actually got 2 computers or not be able to found, but actually they were found by Tsinghua University. So the photo, yeah, the display you're seeing right here has all the things you see in that photo, which is impressive. Yeah, I want you guys to take a look over here. I think this is, I don't know, I'm just guessing. This looks like from the 90s.
Evolution from the old computers to the relatively new over there.
Exactly, that's right. I think this computer is from, I don't know, 90s, because that looks like my dad used to use, I don't know.
That's a Chinese computer.
Chinese computer, that's from 1984. It's a little bit earlier, yeah, than the one that I used to use. Okay.
And these are computers that look newer and newer. This, well, let me see. This is actually the first Mac computer, one of the first.
First Mac.
It looks nothing like a modern Mac, of course.
Oh, you can see the Apple logo, see?
Yeah.
The Apple logo there. And it's portable, is it?
Yes, barely.
Wow. I remember this one. That's very beautiful color. Beautiful color.
This is the first iPad.
First iPad. Wow, look at that. Look at this, is incredible. And this is the desktop.
Yes.
iMac.
iMac computer.
Interesting. These are all very nice color. Have you used the iMac before? I don't know, Adrian.
Me? Oh, I've never used an iMac.
No?
Personally, I have friends who does, and I think it's really cool. And I've seen them before, and it's revolutionary.
You can definitely keep them. Yeah. Okay, take a look at this.
Then the computers evolved into these monsters. This is a supercomputer.
Supercomputer.
It is not portable in anything, but it can calculate things much faster and much harder than any of these can ever do.
Yeah. Interesting. Do you want to tell us the story about this little flag here?
Well, there's not much of a backstory about this little flag. This computer is Chinese, so that's why.
I think there's a group of kids used to tour here, and this little kid heard about the story of this Chinese machine, and he was really proud of what Chinese can do, so he left the flag over here. So it stays, it stays here.
It's an interesting story.
Yeah, very interesting. So go ahead.
This is called the Tianhe. And it's one of the largest supercomputers in the world. Of course, this is just a tiny section of the computer.
Yeah.
The original, you can see, is this picture. And it's absolutely enormous with rows and rows of storage and computing systems.
We got Linda says, you are brilliant. You are such a, he did such a wonderful job. So this is actually the end of this exhibition, right?
Yeah.
Yeah, and I saw that actually, it does remind me about the smartphone that we are using today, because nobody would call it its calculation device.
Yeah.
Right, but it's actually, you know, a lot of things.
Started as a calculation.
Yeah. So it's really pervasive. It's everywhere. The calculation is actually invisible. It does make me think about that we are already or about to enter the era of the artificial intelligence. So it's a very wonderful tour here, and thank you so much, Zongshu, to help to provide us all those great information.
Thanks.
Thank you, and yeah, we are here, and thank you, Adrian, for joining us. Today we toured the Tsinghua University Science Museum, and I hope you guys had fun today. And I'm Caroline Gu. Thank you so much for spending time with us, and we'll see you next time. Bye.
Bye.